Hello, this is Thomas Van Bommel for PROG2200 Module 02 Vehicles by Inheritance. 3D land and air vehicles rendered in text, no 3D display. So the assignment is to create 3 classes: a vehicle class that has position, speed, and direction, a land vehicle class that has gas pedal, brake pedal, and steering, air vehicle class, height, propeller, and steering wheel. So we'll start with the vehicle class here. And here we go. So I've got my vehicle class here. It holds a transform, which is in my utility package here. A transform is just an object that holds a position and rotation. They're vector 3 floats, and the vector 3 float class is just simply XYZ, and then you have methods to add, methods to multiply, and methods to cap the result using modulo. And so there's that guy, the transform. There's also a forward method, which will tell you the forward facing of that object based on the rotation. It uses cosine and sine. And then back to the vehicle class here. So we have the transform. We've had this random function for when we want to create random controls, or like a nudge, or in this case a time to nudge. So the next value here, time to nudge, is simply counts down here in the update method, and as soon as it's less than or equal to 0, it sets itself to another value, random value between 0 and 10, and then nudges the vehicle. And nudge is an abstract method down here that any child classes would have to inherit and include. Other than that, the update method here also translates the vehicle, so it moves it based on the forward vector 3 from the transform, and then the speed of the vehicle itself. And this next function just tells you how much it's going to add on to position. So up here where we're translating, technically probably could have used the next inside the update function, but I didn't. And this is just so in my main method I'm able to keep it in bounds later on in the assignment. Next one here is an abstract method get speed, just to get the speed of the vehicle, because our land vehicle has a gas pedal and our air vehicle has a propeller speed, so I wanted a way to get that from both. Change, simply you give it an amount, and half the time it'll give you the positive amount and half the time it'll give you a negative amount. Good for random values and just used in the land and air vehicles both, so I thought I'd include it in the parent class. After that, we've got this limit method, which is just another utility method basically for the air and land vehicle class that just limits the value between a minimum and a maximum. And then toString just simply prints out the string, which I'm noticing has got a lot of extra text in here that I didn't want. I don't know, must have been copying something. Yep. Alright, so that's the vehicle class. The land vehicle class we'll move on to next. The land vehicle class is just an extension of vehicle. It's got a throttle, braking, and steering values, which were requirements. The constructor just creates a default vehicle, which just uses a default transform, which just sets all the vector 3 position and vector 3 rotation to 0, 0, 0. And so this random vehicle simply gets a random result for throttle, random result for braking, random result for steering, and a random rotation on the I have it on the x-axis, but it's actually top down, so it'd be like the z-axis. But in this code, and the way I wrote my transform class, it's the x-axis. So, and then it returns the result. The update method simply applies steering to the rotation every time to get like a car-like steering, because if you turn the steering wheel 10 degrees, you're going to keep turning, and it's going to keep adding rotation to your vehicle, whereas instead of just keeping it 10 degrees and just, going at 10 degrees, it'd be a sketchy way to drive cars. And then calls the parent update method to move the vehicle. Then the nudge method here simply changes the steering by a random amount, and that random amount is later on in the assignment. And so it would limit the steering from -1 to 1, -1 being fully left, 1 being fully right, 0 being straight. And then minus is a random amount from it. Throttle minuses or adds a random amount from it, limits it from 0.5 to 1. And then braking does the same, except it limits it to like 0.2. ToString is just a string representation of this vehicle. Some getters and setters, and then the getSpeed method, which just returns throttle minus braking. Next is the air vehicle class. Similar to the land vehicle class, it extends vehicle, except this one has prop speed, joystick, controls X and Y, minimum height, maximum height, and a target height. You create it with the minimum height and maximum height as parameters in the constructor. Create random air vehicle is just going to randomize the prop speed, joystick, axis, and the rotation on the XY plane, and then return the result. On the update method, we just call the parent update to move the vehicle, and then we do kind of a similar thing here with our joystick x-axis as we did with the car steering wheel, so that gives it constant rotation. And then this is basically all just to maintain the target height, and so also the minimum height and maximum height. We don't want to go too high, too low, but we also want to have randomness in the flight so it looks like a simulation. Nudge just simply nudges the target height, prop speed, and joystick so that it looks like someone's flying again. String representation of the object, and then the speed of the vehicle returned at the bottom. And that's the air vehicle class. Simulation that creates 3 land vehicles, 3 air vehicles, and a loop performing the following. Give a vehicle a random setting for speed, direction, and all other settings. So if we go to my simulation in the main method here, I've got a viewing area, which is a 100 by 100 by 100 cube. I've got 6 vehicles in a vehicle array. And then our loop, we're just simply doing a while true because I just stop it when I want it to stop. And so inside this loop here, we have this useless I, which I'll get rid of. And for each vehicle, we're simply printing out the vehicle's XY position. We won't do that at first. We'll print out the vehicle string here. And that's why we had our I. And then we update the vehicle, and then we call this keep in bounds method. This keep in bounds method is designed to keep the vehicle inside the viewing area. So it simply checks, if I can tell which direction this is. Checks the X to see if it's less than, so this is checking the left hand side. Oh gosh, I have it in text right there. So we have a check left, check right, check front, and check back, which simply grabs the next method I talked about earlier, which grabs like the next movement going to be applied to position on the next frame, and if it's less than the edge of the frame, then we're going to keep rotating in a while loop up to 180 degrees, and then we just reset that and we do that for all sides just to check, and that keeps it inside the bounding box. Then we simply sleep for a second as per the requirements and repeat. And if we see that running here, you see that we get, oh gosh, looks like I might have had some other text issues, but this simply prints out each vehicle and all of their stats. So it prints out 6 vehicles each frame. It's a little hard to read this way, so I have a couple other options here. One of them is just to print the XYZ of each of the vehicles all in one line, so that it could be easily put into like a spreadsheet or something, and that's what this looks like. So each second we'll get one line with all the positions of all the vehicles, and this can be easily copied and pasted into a spreadsheet. And we'll stop it there. So you can see our vehicle 1 here at 0.13, 0.750. It's clearly a land vehicle because it doesn't have any height. And you go to the air vehicles and you can see they have height. The vehicle is updated periodically every second and changes position depending on the steering wheel or propeller or whatever. So every second update, that's the sleep method there. And then changes every second periodically, or every 10-second periodically. Oh, sorry, that's the next one. Every 10 seconds, the controls are randomly nudged in a direction or another to simulate someone at the controls. Again, we go back to my vehicle. We have this TTN variable, which is time to nudge. It is going to be a random value between 0 and 10 and counts down every frame. And when it gets down to 0, it nudges the vehicle. And as we saw in land vehicle, the nudge adjusts the steering, throttle, and braking, and the air vehicle nudge adjusts the target height, prop speed, and joystick X. The vehicle rebounds from outer boundaries so it stays within your viewing area. So if we go down here, and we can see the keep and bounds method, that is exactly what that guy does, and I will show that off a little bit later inside of a spreadsheet. The text shows the location each second in XYZ format capable of being loaded into a spreadsheet. Again, I will show you, well, let's do that right now then. So if we just go to Google Sheets. There we go. We can just, I'll show you that this can be copied and pasted in there. Oh. Whoops. And there we are. Easily pasted in there. All the values come up nicely and in their own cells. Now this is what I would do to show this off a little bit better, is we're going to have just the one vehicle. I'll make it a land vehicle. And we're just going to print out the one vehicle's position. And we're only going to print out X, Y so that I can put it on a graph here too. we'll just speed this up so we're not waiting all day. Press play. And we get a bunch of positions here. We'll let it run for a second. Stop it. Oops. Collect all that data. Copy that. And we'll go into our spreadsheet and delete everything. Paste it in. And then we insert a chart. Oh, don't call me a liar. There we go. Add the x-axis to be A. And then remove A from there. And we can see the path. So we can see that because we set a queue of 100 by 100 by 100, he won't go above 100. And we set a minimum of 0, so he won't go below 0. And he won't go past 100. Or if he does, he starts turning around until he comes back into the viewing area. And he does have a random driving pattern, which is quite nice. Back to the assignment here. The physics of the movements do not need to be perfect. Test one vehicle at a time. Alright, so actually I guess that was the end. So this has been Module 02 Vehicles by Inheritance by Thomas Van Bommel for PROG 2200. Thanks for watching.